So now we put primers in there. Those primers have a 3' end to them, correct?
Yes.
So on those 3' ends, we can add new nucleotides. And what's going to do that for us?
The
RNA polymerase? Do we want to make RNA here? Think about the whole purpose of doing this. Why are we doing PCR? To
Have a bunch of copies of one thing.
amplify DNA. Obviously didn't look at your notes last night.
Oh.
Well, this should be a fun quiz on Thursday.
Oh, this should be a fun quiz.
So we need this guy, DNA polymerase.
Oh, it's right there.
Hey, Anvi.
Yeah.
Anvi.
Yeah.
Anvi.
Yeah.
What's the optimal temperature for enzymes to work at?
Enzymes?
Hmm? 37 degrees Celsius, right?
Okay, I was thinking 39 or 37.
Yeah.
Hey, I thought we lowered during PCR, we lowered it down to like 50.
Hey, you close your mouth. You've already
One
done
was
this.
50, 172, the other was 96.
Let me form the minds of these people. You can't open your mouth till the bell rings. Hey, Anvi. No, don't say anything.
Hey, I
Nothing.
didn't finish that last
Doesn't matter.
slide.
Doesn't matter.
Anvi.
What temperature does DNA start to denature?
95
Which one?
95.
95?
Celsius.
Start to denature?
No, it's
95 is pretty good to make it all denature. But we're going to start right about there. Remember when we did our DNA extraction?
Yeah.
We had an elevated temperature in those to degrade all those wonderful things that we didn't want. So as long as we kept the temperature during the extraction below this, did we do anything to the DNA that we were extracting?
No.
No, we were good, right?
Yeah.
Okay.
Why'd you make it Celsius though?
Because that's what temperature you work with in
Well, we're in
science.
America.
Excellent. Glad you know where we're at.
Why would you use Fahrenheit?
So Abby, what temperature do proteins such as enzymes denature then if their optimal temperature is 37 degrees Celsius? Think about your
25.
fevers. By the way, 37 degrees Celsius is around 98 degrees Fahrenheit for you Americans.
Huh.
Thank you.
You're welcome. Where were you born?
Huh?
Where were you born?
Burn.
Where was I born?
Yes.
In the Philippines.
East LA? Oh, you're not American.
I'm an American citizen.
Are you?
Yeah.
Excellent.
I know. I love America.
Where were you born in America?
I wasn't.
Okay, just
Born in
checking.
the Philippines.
So then
Oh, he's just
you're
happy.
familiar with Celsius.
I'm tropical.
Hey, I was right.
You never said it.
So we have a big problem here, by the way, if anybody's picking up on this.
I don't
I would
care.
certainly hope somebody...
We're gonna denature the enzyme, the DNA, but
There
not
should be your clue,
denature.
too.
Is that a copier?
It goes through cycles. Yeah. Okay.
Yeah? And?
Heats up and then goes down. Heats up
Right,
and goes down.
heats up to...
65.
Heats up to...
What?
You have your notes right in front of you.
65?
No.
No. No.
95 degrees Celsius.
So does anybody see a problem with this?
Yes.
Other than Kirsten? Who knows where I'm going with this? So don't you say anything. What's that?
One is the nature before the other.
Who's going to denature? The enzymes are going to denature before we even get to make copies of them. This is bad, right? Don't you say anything. We've got to solve a problem here, right? Good thing Carrie Mullis was a surfer, dude.
Is there like a solution we can add to the DNA that makes it denature at a lower temperature?
No, but that's a great idea. I like your idea, Nick. And I'm glad you were thinking of solutions. Can you think of any other solution? Think the way we've been solving this so far. All these problems that come up.
Salt water. We use salt water.
No, today, all the problems we've been solving today.
Oh.
I don't even